Okay, let's review where we are in the outline. We have just finished examples of translate expressions, and so that takes us now to equations, and we're going to solve several different kinds of equations. So we need a routine to solve equations. What's the routine to solve equations? Here's a pretty good routine right here. Okay, check first for these things in order. So check first to see if you have fractions or decimals. So you want to clear the fractions or decimals and simplify each side of the equation. Then check to see if you have parentheses. Remove the parentheses with the distributive property and then simplify each side. If you don't have fractions or parentheses, you get to skip these steps, but they're good to do first. Use the addition, which can also be subtraction property, to isolate the variable term. That means get the x term or variable term on one side. And then last, use the multiply principle, and remember that could also be the divide property, to isolate the variable itself. Alright, and then remember that we have equations that are conditional, which we find a solution or solutions that work. Then we have equations that we call an identity and equations that we call contradictions. Alright, and we'll see examples of these. Okay, let's start with 5a is equal to negative 15. So we have no fractions, no decimals, no parentheses, nothing to move around. We're at the step, we only need the last step because the variable term is on one side by itself. We only need the last step to divide. The multiply principle says we could multiply by 1/5, the reciprocal of 5, but it's just easier to show divide by 5 on both sides here. Now, we do that because 5 over 5 is 1, and that gives us 1a, and we don't write the 1, we just write the a. And on this side we do the division. Negative 15 divided by 5 gives us negative 3. And remember, you can check your work. Okay, how can we check it? Rewrite 5a is equal to negative 15. And then 5, replace the a with negative 3 and bring down your negative 15. This side has math to do, so 5 times negative 3 is negative 15, and at that point we see that the two sides match our solution checks. But the solution is a is equal to negative 3. Let's take a look at this equation. 8y minus 8 is equal to 37 minus 7y. Here we do need to use the addition subtraction principle because we have y terms on both sides. Okay, so we want to, let's say that we would like to zero out a minus 7y. So that would take a plus 7y. What we do to one side we must do to the other. And so this is a big 0 now, and we don't have to write plus 0. This we get 15y minus 8 is equal to 37. Now we could use the addition principle again, so we would add positive 8 to 0 out the negative 8. Positive 8 here. Now that gives us 15y, that zeroes out, is equal to 45. And we're now at the step where all we need to do is divide by 15 to get y by itself. And that gives us y is equal to, and the division 45 divided by 15 gives us 3. Y is equal to 3 is the solution. And remember that you should run the check as we did earlier. look at the equation 8x plus 4 is equal to 2x plus 9. Okay, several ways to show your work for these, and so I might show some of them a little differently. But it's the same work, just shown differently. Here we have 8x plus 4, 2x plus 9 connected by an equal sign, so we know we want to solve for x. So we want to get the x terms to one side. So how could we zero out 2x? How about with a minus 2x, which is the same as plus a negative 2x. So this side zeroes out, doesn't it? So that's a way to show that it zeroes out. And then we could, on this side, collect like terms. Negative 2x plus 8x is 6x. Bring down your plus 4. And here we have only the 9 left. At this point, we're interested in zeroing out the positive 4, or plus 4, so we could have 6x by itself. So that would take a negative 4, a minus 4, or a negative 4, so minus 4 is the same thing as plus negative 4, same thing as minus 4. So over here this zeroes out, and we're left with 6x. And over here we have the number 5. And now all we have left to do is divide both sides by 6. And we get x is equal to 5, 6. Now if you do division with a calculator, you get a decimal number, and it's a repeating decimal, so you'd want to leave it as a fraction, a simplified fraction, and 5, 6 is a simplified fraction. And on a test, you would want to take the time to substitute that back into your original equation and check. Okay, let's look at this equation here. 6x minus 11 is equal to 43. A little easier than the others maybe. To zero out a negative 11 would take plus 11. So plus 11 on both sides. Now remember that zeroes this side out. And we have 6x is equal to 54. And now we're left to just divide both sides by 6. And that gives us x is equal to 54 divided by 6 is 9. And that's a good solution if, when you replace it, 9 for x in the original, you get a true, it checks because you get the same number on both sides.